Hi class, today we're going to review system of linear equations. So it's important that you recognize what type of system that we have. First, let's just take a look at the system of linear equations, and later on we're going to consider the nonlinear as well. So let's take a look at the first example that we have. We have two linear equations. In order for us to have a solution for the system, the order pair has to be the solution for both equations. So for example, let's check whether to see -1 is a solution of the system, is the solution to the system. So first I'm going to check the first one. So if I have -3 times -1 plus 2 times 1, what's that? That's going to be 3 plus 2, which is 5. So check. Now, let's take a look at the second one. So the second one, we have -4 times -1 minus 3, which is 4 minus 3, which is 1. So we're good with this order pair. So this is a yes. Now let's try 0, -7. So if I plug it in for x, 0 there, 2 times -7, I ended up with 14. I'm sorry, -14. Now you can see that is not 5. So this is not right. And then you can just stop right here, because as long as one equation fails, we do not have a solution to the system. Okay, so let's take a look at the graph. So you see right here, I have system A. So the system A, we have line 1 right here and line 2 right here. You see, in order for us to have the solution of the system, that solution has to be the solutions of both lines, right? Which is the intersection right here. So this system is a consistent independent. So what we have is we have one unique solution, which is 2 and -2. Okay, so like I said, the system is consistent and is independent. So it's right here. All right, let's take a look at system B. You see the system B, the line 1, line 2. They're both, I'm not looking at the equation. I'm just purely looking at the lines right here. So the lines are, you see the lines are right on top of each other. So this system has infinite many solution. So this system is consistent, but it's dependent. Okay, and it has infinite many solutions. So moving on to system 3, you see that system 3, we have two parallel lines. So this system is inconsistent. So when you have the same slope, you have parallel lines, and they never cross, they never intersect. So we do not have a solution for this system. All right, solving the equations, the one way to solve equation is we graph and then we look for the intersections. So this one right here, we can graph it easily. Before I'm graphing, I just want to change it to slope y-intercept form. So what I have is -2/1 for the slope, and I have 4. That's the y-intercept, and then we go down 1 to the right 1. So it's right here. Okay, now let's try the other one. The other one is -1, and then I have -1 to the right 3 right here. And you can see that that's going to be the solution. Okay, so that's going to be the solution right here, the intersection that we have. So we can read the coordinates, which is 3, -2. Okay, so graphing is quite easy. Now, the problem is when you have fraction, it's really hard for us to read the coordinates. Therefore, we should use substitution and elimination. So number 10 right here, substitution, really simple, especially when we have one variable already isolated. So in this case, you can see that x is already isolated. So all I have to do is take this and plug it in here for x. So I have 4. Instead of x, we're going to write 2y plus 5 plus 3y equals -2. The whole point is to get to only one variable, because with one variable, you can solve it with one equation. Okay, two variable, you need two equations. So I'm sorry, I'm running out of space. So I have y is going to be -2. So I then going to take y and plug it in here. So x is going to be 2 times -2 plus 5. So x is 1. So my solution, 1, -2. All right, now that one is easy because, like I said, we have one variable already isolated. Okay, so if you have something like this, you should use elimination, and especially when they have the 4y and 4y for you easily, right? So I can just subtract. So if I subtract, I get 2x. I cancel out one variable. The whole point is to cancel out one variable. Okay, so you do what you can to get rid of one variable. That's why we call it elimination. So we eliminate one variable. Now I got one variable. I got -8 for x. I'm just going to go back and plug it in. So notice that I can use the first or the second equation. Really doesn't matter. You pick the equation that you think is easier for you. So y is 9. All right, if you have something like number 12, you see that they're all different. We're going to pick one, we're going to eliminate, right? So I'm going to pick one and find the opposite. So, and to create the opposite. So you see that I have -5 -5y and positive 2y. So in a way, I have a negative and a positive already. So I'm just going to have to make the opposite now. So I'm going to multiply the top one by 2 and the second one by 5. Okay, so I ended up with 12x minus 10y equals -14. On the bottom, I have 25x plus 10y equals 125. Okay. Now I'm gonna go ahead and add to eliminate one variable. So I ended up with 37x. And then I have 111. I divide by 37. I get 3 for x. And then I'm going to go back and plug it in for y. So I'm going to use the first equation. So 6, I'm going to plug it in for x. So I get 18 here minus 5y equals negative 7. Negative 5y, negative 25. So y has to be 5. Okay. Sometimes people go back to the original and create the opposite for x this time. So we eliminate x and then we solve for y, just like how we solve for x from the beginning. It's really up to you. Okay, now number 13, when students look at the problems and see fraction, they don't like it. So you can always get rid of fraction by multiplying everything by the LCD to get rid of fraction. So if I want to get rid of the fraction for the first equation, I have to multiply everything by 6. So I ended up with x minus 3y equals 12. Now, the bottom one, I'm going to multiply by 15. So I ended up with 5x minus 12y equals negative 30. Okay, you can see right here, x has just 1 for the coefficient. So this one right here, I would just use substitution for this one. If you want to use elimination, you create you multiply and create the opposite. But I'm gonna try substitution because I believe it's easier. So x is 12 plus 3y. So I have 5 here. 12 plus 3y minus 12y equals negative 30. If you think elimination is easier, you go ahead and do elimination. So what I have here is negative 90, and then when I divide by 3, I'm gonna get negative 30. Okay. Now, since I have y already, I'm just gonna go back and solve for x using this equation right here. It's gonna be easy for me. 12 plus 3 times negative 30. Okay, so x is going to be 12 plus negative 90. So it's negative 78. Okay, don't forget you can always go back and check your solution by plug it back in the original right here. Don't plug it in here because sometimes you make mistake here. Okay, so make sure you always use the original to check your solution. Okay, this one straightforward. I'm just gonna go ahead and add. Now turn out when I add, I get everything cancel out and I ended up with 0 equal to 0, which is a true statement. So when you have a true statement, the system has infinite many solutions, so it's going to be this one. And then to answer y, you can just pick the first one or the second one and isolate y. So I'm going to pick the first one. Okay, so y is going to So y is going to be, when I divide by -2, y is going to be x divided by 2 minus 1. Okay. Now, this one right here, when all the variable cancel out, and I ended up with a false statement, so I have 0 equals to 12, which is false. When it's false like that, that means the system has no solution. So these two have the same slope, these two are parallel, they never cross. So that's why they have no solution. All right, moving on to some application problems. So for application problems, you need to read the problems carefully, come up with the variables, then use the variables to write the equation, then solve the equations. So we have two mechanics working on a car. The first one worked for 5 hours, the second one worked for 15 hours. Together, they charged a total of $14.75. What was the rate charge per hour by each mechanic if the sum of two rates? So what you have right here is you have the sum of two rate and the total charge. Okay, so the first thing we need to come up with is the variable. So they're asking you for the rate charged per hour by each mechanic. So how about I call the rate of the first mechanic X and the rate of the second mechanic Y. I know the sum of the total, the sum of two rates is 155. That means I have X plus Y equals 155. Now for the total cost, for X, the first mechanic works for 5 hours, so we multiply by 5. The second one worked for 15 hours, so we multiply by 15. And it should add up to 1475. And then from here, you're going to use substitution, elimination. It's really up to you. I'm going to use substitution. So I take 5, instead of multiply by x, I have 155 minus y. Make sure you analyze your solution. So y is 70. So I have the rate of a second mechanic is $70 per hour. Now, going back to solve for x is going to be really easy if you use this equation right here. So it's going to be 155 minus 70. So it's 85 for the first mechanic. That's his rate. Okay. All right. Moving on to number 16. Usually for problems like number 16, I try to draw so I can visualize. A scientist has two solutions, so she labels solution A and solution B. So I'm going to draw the beaker. Also, this is A and this is B. Okay. So each contains salt. She knows that solution A is 30% salt and solution B is 55%. So 30% and 55%. She wants to obtain 130 ounces of a mixture. So a mixture right here. So pretty much when she add them up, she get this mixture with 130 ounces in it, and is 35% salt. Okay, and then we're asking how many ounces in each. So I don't know how many in here. I don't know how many in here, so I'm just going to put X and Y. All right, so you can see that based on this drawing, you can see that X plus Y is going to be 130. That's going to be the first equation. The second equation, we have the 30%. So I'm gonna have 0.30 x plus 0.55 y is gonna be 0.35 multiplied by 130. And then from here, you just solve for x and y, right? Okay, so once again, I'm gonna use substitution because to me, when the variable is isolated, substitution is gonna be easy. I'm gonna go ahead and distribute. So after I divide, I got solution B is going to be 26 ounces. Okay. For solution A, like the previous problem, I'm going to use that one. So after you subtract 26 from 130, you should get 104. Okay. All right. So number 17, when you read the problems and you see hours, you see miles going upstream, downstream, you know this is a motion problems. So what we have is D equals to RT. D is for distance, R is for rate, and T is time. Now, for this problem, I recommend you to make the table. So we have going upstream. When you go upstream, that means you go against the current. They're asking you what is the rate of the boat and what is the rate of the current. So we have going downstream, which is with the current, and going upstream is against the current. And like I said, we need R, T, and D. Okay, so the rate of the boat and the rate of the current, I'm just going to call the rate of the boat B and the rate of the current C. So you see right here with the current is going to be B plus C. Against the current is going to be B minus C. A motorboat takes 4 hours to travel 128 miles going upstream. So the So D for against the current is going to be 128, and the time is going to be 4. Return is going to take 2 hours. Faster when you go with the current, go downstream. Now, because you're going to go downstream, so you go the same distance. So it's going to be 128. Now from here, you use the distance formula right here and you plug it in. So I'm just going to go ahead and do T first. So 2 times B plus C equals 128. 2B minus C equals 128. You can see that we can distribute, or I can just divide by 2 from the beginning. This is a 4. I'm sorry. So I have B plus C equals 64. And for the second equation, I have B minus C equals 32. And then you can see that if you add them up, you cancel out C. So 2B equals 94. I'm sorry, 96. So B is going to be 48 miles per hour. And then you use substitution, you go back and you get C. So if you go back and you solve for C, it's going to be 16 miles per hour. You can use any equation. You can use this equation, or even you go back and use the original equation. It shouldn't be a problem. All right. Now, moving on to system 3 by 3. So when you have 3 variables, you just like having 2 variables, we go from 2 to 1. So for 3 variables, you want to eliminate 1 variable at a time. So we go from 3 to 2 and from 2 to 1. For these types of problems, make sure you organize it. Okay? So when I look at the problems, I see that I can eliminate the x. So I'm going to pick x to eliminate first. So if I'm just going to label it. So this is A, B, and C. So if I add A and B, I'm going to eliminate x. So I'm going to get 3y plus z equals negative 7. Now I have to go back, pick 2 different equations and eliminate x as well. So I'm going to pick, you can pick the first one and the third one, or the second one and the third one. I'm going to pick the second one and the third one. But before I add, I have to make them into the opposite. So I have to multiply 2 by b. So I have to take 2b and then I plus c. 2b, if I multiply 2b, I'm going to get negative 4x plus 4y minus 2z equals negative 10. And then I add with c, I'm going to get, cancel out x, 4y plus y is going to be 5y. And then somehow I cancel out z as well. So negative 10. Okay. So this one is actually a very easy problems because from here you can just solve for y. So y, you see that is negative 2. Now because I get y already, I can go back here and solve for z. easily, right? So I'm going to take this 3 times negative 2 plus z, negative 7. So z is negative 1. So to solve for x now, I just have to go back to a, b, and c and uh, plug it in for y and z. So I have 2x, I'm going to use a. 2x, y is negative 2, so negative 2 plus 2 times z is negative 1 here, negative 2. So from here, we just solve it. Negative 2 minus 2, so it's negative 4. Negative 2 here, 2x equals to 2. So x is 1. So we got it. We got x, we got y, and we got z. All right, moving on to number 19. So 19, you see that we do not have a linear, we do not have two linears. We have a linear and a quadratic. However, what we have is we have y and y. So technically, you can set them equal to each other because they are just y and y. Okay, so I'm going to set them equal to each other. X squared plus 7x minus 3 equals negative 4x minus 21. So you can solve them as a quadratic equation. So we have to move everything to one side to get the standard form. So I'm going to move everything to one side. So I add 4x and I add 21. So I ended up with x squared plus 11x plus 18. Now the goal here is I'm going to try to factor first. So I'm going to pick two numbers. When you multiply, you get 18. When you add, you get 11, which is 9 and 2. So what I have is x equals negative 9 and x equals to negative 2. We're going to go back and solve for y. So you see that we have two x's, so we're going to have y for x equals to 9. We have negative 4 minus negative 4 times negative 9 minus 21. I pretty much pick the easy one to solve. So the easy one would be the linear. You can go back and use quadratic to solve it, but why, right? Because solving linear is easier. So I have 15 for the first y. And then the second y, I have negative 4 times negative 2 minus 21. So it's going to be positive 8 minus 21. So that's going to be negative 13. Okay, so I have two order pairs. Negative 9s go with 15. And then we have negative 2 go with negative 13. So we have two solutions. Now, I just want to show you that you know that quadratic is a parabola, right? And then a linear, so you probably have something like that. Therefore, we have two solutions. For number 20, you can definitely rewrite the equation so you get something like number 19, and then we put them together. Or you can always eliminate y and we just have to deal with x, right? So if I want to eliminate y, I'm going to have to multiply the second one by negative 1. So I can get a positive y. So if I multiply the second one by negative 1, I ended up with 4x squared plus 5x plus y equals 1. And if I add the second with the first, I'm going to get 8x squared plus 12x eliminate y equals 8. Now we are back to quadratic, so I can just go ahead and factor. Now you see right here we have a GCF, so I'm just gonna take it out. So the GCF here is 4. So if I divide everything, if I take out 4, I ended up with 2x squared plus 3x minus 2 equals 0. Okay, and then from here you can just factor. You can ignore the 4. I'm gonna factor, so I get negative 4 here, 3. I'm gonna pick two numbers. When you multiply you get negative 4. When you add you get 3. So it's gonna be 4 and negative 1. Okay, so I'm gonna use my method. I take 4 divide by 2, that 2 right there, and then I take negative 1 divide by 2, then you reduce it. So now we are ready to write. So I have x plus 2, and then I have 2x minus 1 is right here. So I have put x plus 2, 2x minus 1, okay, equals 0. So for the x, I have negative 2, and x equals to 1/2. Okay, and then once again you go back and you solve for y. You can pick the first one or the second one. So you're gonna get, for negative 2 you're gonna get negative 5 for y, and then x you're gonna get negative 5/2 for x equals to 1/2. So you can just go back and plug it in here or in here. Really doesn't matter.